The formation of ice crystals and snowflakes is a captivating process governed by the principles of physics and thermodynamics. The intricate and symmetrical structures of snowflakes result from the unique conditions under which ice crystals grow. Here's an exploration of the science behind the formation of ice crystals and snowflakes. 1. Nucleation. Initiation of ice formation. The process begins with the nucleation of ice crystals. This can occur when water vapor in the air transitions directly from a gas to a solid, sublimation, onto tiny particles or surfaces that serve as nucleation sites. These particles might include dust, pollen, or other airborne particles. 2. Growth of ice crystals. Hexagonal structure. Ice crystals are composed of water molecules arranged in a hexagonal lattice structure. The hexagonal symmetry is a result of the hexagonal arrangement of oxygen atoms in the water molecule. Branching and faceting. As the ice crystal grows, it may branch and facet due to variations in temperature, humidity, and the presence of different water vapor sources. These factors influence the growth rate of different crystal faces. Temperature gradient. The temperature gradient around the growing ice crystal influences the rate of growth on different facets. Varied growth rates result in the development of intricate patterns and structures. 3. Conditions for symmetry. Ideal conditions. For a snowflake to exhibit its characteristic symmetry, it needs to grow in relatively consistent and stable conditions. This means a consistent temperature and humidity level as the snowflake descends through the cloud. Plate-like crystals. In certain conditions, ice crystals may take on a more plate-like form. This occurs when humidity is lower and the growth is more uniform across crystal faces. 4. Dendritic growth. Dendritic snowflakes. Dendritic growth refers to the branching and intricate pattern formation seen in many snowflakes. This happens when there are variations in temperature and humidity as the snowflake descends through the cloud.
Branching patterns.
The specific branching patterns of dendritic snowflakes result from the complex interplay of environmental conditions and crystal growth dynamics. 5. Rimming and aggregation.
Rimming.
Rimming occurs when a snowflake encounters supercooled water droplets in a cloud, causing the droplets to freeze onto the snowflake's surface. This process can lead to the formation of graupel or hail.
Aggregation.
Snowflakes may collide and stick together, a process known as aggregation. This results in larger and more complex snowflakes. 6. Final snowflake structure. Unique snowflake designs. Each snowflake develops its unique design based on the specific path it takes through the cloud, the varying environmental conditions it encounters, and the interactions it has with other ice crystals. 7. Influencing factors.
Temperature and humidity.
The growth and structure of ice crystals depend heavily on temperature and humidity conditions. Small variations in these factors can lead to the formation of diverse snowflake shapes.
Supercooling.
Supercooling occurs when water droplets remain in a liquid state below the freezing point. Ice crystals forming on these supercooled droplets create the initial structures of snowflakes. 8. Formation in clouds.
Cloud composition.
Clouds serve as the birthplace of snowflakes. The presence of water vapor and the right temperature conditions within a cloud contribute to the formation of ice crystals.
Cloud seeding.
Cloud seeding involves introducing substances into clouds to encourage the formation of ice crystals, potentially enhancing snowfall.
Conclusion.
The science behind the formation of ice crystals and snowflakes is a remarkable blend of physics, chemistry, and atmospheric science. The delicate and intricate patterns we observe in snowflakes result from the complex interplay of temperature, humidity, and the unique journey each snowflake takes through the cloud. Studying the formation of ice crystals not only deepens our understanding of the natural world but also allows us to appreciate the beauty and uniqueness of each individual snowflake.